of multi-program. A single program cannot, in general, keep either the CPU or the I/O devices busy at all times. Single users frequently have multiple programs running. Multi-programming increases CPU utilization by organizing jobs so that the CPU always has one to execute. The idea is as follows. The operating system keeps several jobs in memory simultaneously. Since in general, main memory is too small to accommodate all jobs, the jobs are kept initially on the disk in the job pool. This pool consists of all processes residing on disk awaiting allocation of main memory. So you can see this picture. Here in the main memory, we have 4 jobs. Okay. And at the same time, in the main memory, we have 4 jobs in the main memory together. Okay, so how to realize multi-programming? Let's see this picture. The red line representing CPU work, and the blue line representing I/O work. So you can see first job 1. It gets CPU and began to running. After a while, it will do I/O. It requires I/O. So the scheduler, the monitor part, the scheduler will schedule the CPU to job 2. The scheduler begins to work and schedule the CPU to job 2. Then job 2 began to run and job 1 began I/O, printing some materials. After a while, job 2 wants to do I/O. Then the scheduler work again. It will schedule the CPU to job 3. Then you can see now job 2 read data from the disk, and the job 3 begin to execute on CPU. After a while, maybe job 3 will do I/O again, want to do I/O, and the scheduler will work again. It will schedule the CPU to job 1 again, then the job 1 run again, continue to execute. So here from this picture, we must know some point. One point is this: the job 1 begin to do when job 1 do I/O, his work doesn't finish, and the second time when it finish I/O and schedule CPU again, it will continue to run from that point. Okay, it just stop from that point. From this point, it just stop. So the system or the operating system must record this point, the status of job 1, okay, such as the program counter, the content of register, and the content of some special registers. All this is the first. And the second, here you can see here, I/O device and the CPU work in parallel. Even here, we have 2 I/O and 1 CPU. They work in parallel. Okay, so you can see by multi-programming, the CPU utilization becomes higher, and also the I/O can work in parallel. So, operating system features needed for multi-programming. Okay, first, job scheduling. All the jobs that enter the system are kept in the job pool. It consists of all processes residing on disk awaiting allocation of main memory. If several jobs are ready to be brought into memory, and if there is not enough room for all of them, the system must choose among them. This is job scheduling. And the memory management, because several programs are in memory at the same time, so it requires memory management. And some CPU scheduling. CPU scheduling, which is also called precise scheduling. Finally, running multiple jobs, the system must choose among several jobs which are in memory and ready to run. Allocation of devices needed by jobs that are running. Multi-programmed systems provided an environment where the various system resources, CPU, memory, peripheral devices, were utilized effectively, but it didn't provide for user interaction with the computer. Okay, so here just now